I'm in the Quality Assurance Pavilion here in the East Building talking with Dennis Finn of Nikon Metrology. How are you, Dennis?
I'm doing fine, thank you, Whitney.
So, talk to me about this new product. You're debuting this at the show, is that correct?
That is correct.
All right, so tell me about it.
What I'm going to be showing you today is Nikon's new P3D portable metrology scanner. It's completely portable. You can see here that it's very light, only 1.9 kilograms, completely portable, battery powered. So you can run 40 minutes off of the internal battery, up to 4 more hours with the external battery pack that's available. The memory is saved, or the data is saved on a SD card that you can remove and put into your PC. You also have the ability to save on USB drive, and also if you want to, you can plug this into a monitor with the external DVI output. If you do have a Wi-Fi enabled SD card, you can transport that data automatically to your PC, so you can just leave the card inside.
Well, that saves time.
Yes, it does. So to use the device, what you want to do is point this at the object of interest. So here we have our camera, and this right here is the laser scanner. It's a fringe projection laser scanning. You also have a traditional camera as well as a LED that you can use to superimpose a color image on top of your 3D data.
Okay, and then this is the display that we're seeing here, is that right?
That is true. So what you want to do is, I don't know if you can see, but you want to align the lasers so that you're at the optimal position from the scanner, and then to set the exposure so that you have the correct exposure on the system, you just want to touch the object that's under interest on the screen. Once you've done that, I can hit the capture button to capture the 3D point cloud. You can see it's capturing that cloud right now. It only takes a few seconds.
That's scanning it. Wow, that's really fast.
And it's reconstructed the image here on screen. At that point, you have full control to manipulate the data. You know, I can zoom it in, zoom it out. I can rotate. If you get it into an orientation that you don't like, I can just press the button. It goes back home to where the orientation when the data was captured. There's built-in measurements in the device. You can do measurements on screen. You can do point-to-point, plane, plane-to-plane, sphere, sphere-to-sphere, cylinder, cylinder-to-cylinder, as well as cross-section. So I'm just going to show how simple it is to do a measurement here. I chose the cross-section. Just going to cut across that, and you can see that I have the cross-section displayed on screen.
Wow. So what are the applications of this?
Would be for measuring samples that you want to be able to take the device to, that you can't bring that sample to traditional, because we do have laser scanners on that are on ARMS or CMM.
So what is an example of an industry? It's like automotive industry?
Automotive is where it's aerospace. There's even other industries, you know, just plain industrial parts. We have a part here that's one of our Nikon illuminators, and you can see that data that's up on the computer.
So what are we looking at up here on the screen?
This is a 3D representation of the illuminator shell that's been constructed from the data that was collected by the P3D.
And then I understand you can also do 3D imaging of an item such as this, as your gnome here.
Yes, you can. What you would do is you have these targets on here so that the datum can get kept in a position where it's known. And what you can do is just place your object here, and for this instance we just have it on a turntable. And what you want to do is take 5 projections of this image, of this sample. So just rotate it and collect the data. Yeah, just do it 5 times, and you can reconstruct that image, and you have your 3D point cloud, and you can see that I've
3D printed it.
Right here.
Very nice. All right, well, let's see one of your other machines that you brought to the show.
Okay, I'm going to turn you over to Alex Lucas. He's going to show you the CMM with laser scanning capability.
All right, sounds good.
Okay, thank you very much.
Now I'm with Mike Provenzano, who's going to tell us more about this machine.
So we have here today at the IMTS show the VMA 6555 Vision machine. This machine is a true multi-sensor machine. Today we have this set up with 3 sensors. We have vision, we have touch probe, and laser. All 3 sensors are calibrated together so that we can have accurate measurements and use all 3 sensors within a program and have minimal uncertainty.
So what are some of the applications of this machine?
Okay, so these machines are used by many companies. This is used in medical device industry. It's used in automotive, aircraft. It's used in machine tool measurement of machine tools. It's used in plastic components. It's used in. I had a guy here from a company that makes cell phones and computers and stuff yesterday. I won't tell you the name, but anyway, he had like some fruit on him, and then so. Right here we have a machine steel part.
And what is it measuring here?
Okay, so I'm measuring IDs, ODs, I'm measuring flatness, I'm measuring locations of the various features, the IDs, ODs. I'm measuring, some heights and depths of counterbores, things like that. I can actually scan around certain features that aren't geometric, just get a scan of an engineered profile.
So you also have some other scanners here in the booth. How are they different from this one?
Okay, so the other scanners are more for 3D prismatic parts. This is more for parts that I can, sort of 2.5D, parts that I can look at and see the features. Then I can use this machine to very accurately measure them. This machine measures those features much more accurately than some of the other scanners.
Okay, well thank you so much, Mike.
All right, thank you, Whitney.
Be sure to stop by the Nikon Metrology booth here in the East Building.